This video will explore the slope-intercept form of a linear equation. We're going to start by making a table of values for our linear equation, writing down the points that are associated with those values, and then graphing those solutions for this linear equation. After we do that, we'll look at both the slope and y-intercept of this linear equation and summarize the general slope-intercept form of a linear equation. So to start, this table of values has the values of -1, 0, 1, 2, and 3 for x. And we're going to graph the linear equation y equals 3x minus 5. So to complete the column for y, we'll evaluate that equation with x for each of the values given. So plugging in -1 for x, we'll take 3 times -1 minus 5, and I'll put all of this in for this first one. So 3 times -1 minus 5 is going to give us -3 minus 5, which is -8, which means that this will have the point -1, -8. Evaluating this at 0, we'll take 3 times 0 minus 5, and that will give us -5. So the point that we'll have on this graph associated with x equals 0 will be the point 0, -5. Evaluating this equation with x equals 1, we'll have 3 times 1 minus 5, which is 3 minus 5, or -2. So we'll have the point 1, -2. Continuing, we'll evaluate this when x equals 2, so we'll have 3 times 2 minus 5, which is 6 minus 5, or +1. So we'll have the point 2, 1. And lastly, we'll evaluate this when x equals 3, so we'll have 3 times 3 minus 5, which is going to give us 9 minus 5, or 4. So we'll have the point 3, 4. Now we'll go over to my graph, and I'll plot each of these points, and then I'll connect them with a straight line in order to represent the graph of all solutions to that equation. So to start, I'm going to label my axes and scale them. You can see that I need y values to go between -8 and 4, and x values between -1 and 3. So I'm just going to mark these axes off with x and y, and then I have a 10 by 10 grid here, and I'm just going to scale them with 5 and 10 for each the x-axis and y-axis, and then I'll do -5 and -10 as well. Now I'm ready to plot these points, so I'll go to -1, -8, I'll go to where x equals -1 and y equals -8. Continue with my next point. I have 0, -5, so I'll go to where x is 0 and y is -5, and that'll be right on the y-axis. And then I have 1, -2, so I'll go to where x is 1 and y is -2. Then I have the point 2, 1, so I'll go to where x is 2 and y is 1. And then the last one I'm going to plot is the point 3, 4, so I'll go to where x is 3 and y is 4. So I've grabbed my ruler and I've lined it up with these points, and now I'll connect them. Now I'll put arrows on the ends to show that this continues on indefinitely. Looking at the graph, we're asked what the slope of this linear equation is. And so if I look at, I'll make a slope triangle. Going from one point to another, I go up 3 units and right 1 unit. So the slope that I can see is a ratio of 3 over 1, or I could write that as m equals 3. So the slope is 3. And looking at that equation, I see that the coefficient on x is 3. So this is corresponding to the coefficient on x, and that pattern will always hold. next, I'm going to look at the y-intercept, and I can see on this graph that it's the point 0, -5. So the y-intercept is 0, -5. And that value of -5, if I look up at this equation, is the constant term. And so this corresponds to the constant term. If I think about why that holds, the y-intercept occurs when x equals 0. And so plugging in 0 for x will always make that variable term, in this case 3x, equal to 0. And so what I'll be left with is just the constant term when I replace x with 0. So the y-intercept there is 0, -5. The general slope-intercept form of a linear equation we write as y equals mx plus b, where m is the slope and the point 0, b is the y-intercept.